Hello, welcome students. I am Rekha Thorat, Associate Professor. Today we will discuss on the topic partial differentiation. In this topic, we consider functions of two variables. Let us see first definition. A function f from s to r is called a real valued function of two variables of S is subset of if S is subset of R cross R. Now consider definition of partial differentiation. Let z equal to f of xy be a function of two independent variables x and y. Suppose if x changes to x plus delta x and y remaining constant, then z changes to z plus delta z. Because if x changes to x plus delta x, y remaining constant, then z changes to z plus delta z. Hence z plus delta z equal to f of x plus delta x comma y. Hence delta z equal to f of x plus delta x comma y minus z. Z is f of xy. Now we divide both sides by delta x and take limit as delta x tends to 0. So that we get limit of delta z by delta x as delta x tends to 0 equal to limit delta x tends to 0 of f of x plus delta x comma y minus f of xy upon delta x. If this limit exists, it is called the partial derivative of z with respect to x and is denoted by delta z by delta x or fx. Here partial derivative of z with respect to x means here y remaining constant and it is denoted as fx, that is delta z by delta x or fx. Thus delta z by delta x equal to limit delta x tends to 0 f of x plus delta x comma y minus f of xy divided by delta x. Similarly, partial derivative of z with respect to y is also defined as delta z by delta y equal to limit delta y tends to 0 f of x y plus delta y minus f of xy upon delta y. Here partial derivative of z with respect to y is there, so that y plus delta y is there. Here small change in y, so that z also changes to z plus delta z. Hence delta z by delta y, finally we get limit delta y tends to 0 of f of x y plus x comma y plus delta y minus f of xy upon delta y. If this partial derivative of z with respect to y exists, then it is denoted by fy. Partial derivative of z means derivative of z with respect to y, it is denoted by delta z by delta y or fy. Here with partial derivative of z with respect to y, x is constant. There is change only in y. That means here we have studied that delta z by delta x means partial derivative of z with respect to x. When we take partial derivative of z with respect to x, y remaining constant, and partial derivative of z with respect to y, here x remaining constant. Why this derivative is called as partial derivative? Because z equal to f of xy. That means if x changes, then z changes. If y changes, then z changes. That means z depends upon x and y. Z is dependent variable and x, y are independent variables. When there are more than one independent variables, partial derivative exists and it is denoted by delta. So that partial derivative of z with respect to x is delta z by delta x. Here when independent variable are more than 1, we take partial derivative. Otherwise, we have studied uh, till you have studied y equal to function sin x. If x changes, then y changes. Here y equal to sin x, that means only one independent variable x, so that we take only simple derivative dy by dx. But now consider differentiation. If z equal to f of u is a differentiable function of u and u equal to phi of xy, that means z is function of single variable, but this u is function of more than one variable, possesses first order partial derivatives, then dy by z by dy by x equal to dz by du into dy by u by dy by x, which is equal to dz by du means f dash u dy by u by dy by x. That means z equal to f of u. Z is function of single variable, but this single variable u is function of two variables x and y, so that z is function of two variables x and y. If we have to take derivative of z with respect to x, then z is function of two variables, so partial derivative exists, so that it is denoted by dy by z by dy by x. Derivative of z with respect to x is dy by z by dy by x. But we can't take direct derivative. Z is first function of single variable u, so that we have to take first derivative of z with respect to u. Here u is single variable, so that dz by du is there. And then we have to take derivative of u with respect to x. But here u is function of more than one variable. So while taking derivative of u with respect to x, here partial derivative exists dy by u by dy by x. It is f dash u means dz by du and dy by u by dy by y. Similarly, dy by z by dy by y equal to f dash u dy by u by dy by y. Now consider some examples. If z equal to x raised to 4 y cube, find dy by z by dy by x and dy by z by dy by y. First, we calculate derivative of z with respect to x. That is, z is function of two variables. So that partial derivative exists, we have to find partial derivative of z with respect to x, partial derivative of z with respect to y. First, we find partial derivative of z with respect to x, that is dy by z by dy by x. Dy by z by dy by x of x raised to 4 y cube. We know that while taking derivative of z with respect to x, we put y as constant, so that y cube term is taken first outside, and we take derivative of dy by dy by x of x raised to 4, that is only x term. And derivative of x raised to 4 is 4x cube, and y cube multiply it as it is, so that dy by z by dy by x is finally we get 4x cube y cube. That is dy by z by dy by x derivative, partial derivative of z with respect to x, y remaining constant, that is we have to take derivative of x term only, that is 4x cube, and if there is term, any term multiply by it, then we have to multiply it. Now take partial derivative of z with respect to y. Partial derivative of z with respect to y. With respect to y, x remaining constant, so that x raised to 4 term taken outside, dy by dy by y of y cube. And derivative of y cube is 3y square. And x4 is multiplied here, so that here multiplied it. So that finally we get dy by z by dy by y equal to 3x raised to 4 y square. Thus only remember that while taking derivative of z with respect to x, y remaining constant. That is derivative of z with respect to x, take derivative of x term only, that is x raised to 4th derivative for x cube, and multiply the term which is there, that is y cube. And dy by z by dy by y is take derivative of y cube, that is 3y square, and multiply the term which is there, that is x raised to 4. Now we consider next example. If z equal to xy square, find del by z by del by x and del by z by del by y. Del by z by del by x, we have to take derivative of z with respect to x, so that with respect to x, y remaining constant, so that y take y square outside and take derivative of z del by x of x only. And derivative of x is with respect to x is 1 into y square. So that del by x is y square. Derivative of z with respect to x, derivative of x is 1 and multiply term y square, multiply it. So that we get del by x equal to y square. Now consider del by y. Derivative of partial derivative of z with respect to y. With respect to y, then x is constant. So that x term taken constant as outside. Take del by y of y square term. That derivative of y square is 2y, and multiply the term which is there that is taken outside, that is x. So that we get del by y is 2xy. Now consider another example. If z equal to e raised to x cos y, that is z is function of x and y. Z is function of more than one variable, so that partial derivative exists. Find del by x, del by y. First find del by x. Del by x of e raised to x cos y. As discussed, we know that partial derivative of z with respect to x, y remaining constant, so that we take the term cos y outside, take derivative del by x of e raised to x only. And derivative of e raised to x with respect to x is e raised to x, and multiply cos y, so that del by x is e raised to x cos y. That means partial derivative of z with respect to x, y remaining constant. So that take only derivative of x term only, derivative of e raised to x is e raised to x, and multiply the term remaining, that is cos y. Now we take partial derivative of z with respect to y, that is del by y of e raised to x cos y. With respect to y, x remaining constant, so that we take e raised to x as constant and del by y of cos y. We know that derivative of cos y is minus sine of y, so that we get del by y equal to minus e raised to x sine y. That means while taking derivative of z with respect to y, you have to take derivative of y term only, that is cos of y is, derivative of cos of y is minus sine of y, and multiply the term remaining, that is e raised to x. Since with derivative of z, partial derivative of z with respect to y, x remains constant, so that here e raised to x term is taken outside. This del by y equal to minus e raised to x sin y. Thus you can solve any example of finding partial derivative with respect to x with respect to y. Only remember that while taking partial derivative of z with respect to x, y remaining constant, and while taking partial derivative of z with respect to y, also x remaining constant. Same result exists for three variables also. You can solve any example using these rules. Thank you.